Section 11.3 is going to talk about perimeters and areas. So we've been talking about areas so far a little bit, but we're also going to talk about perimeter. But notice it says of similar figures. All right. Now, the good thing about this section is we've talked about similarity before.
Yes, right? We have. We had a whole chapter on it.
We had a whole chapter. So we have some exposure. We should be a little bit comfortable, but it's kind of shocking that this is a section that some students will struggle with because of the new concept. And the new concept is involving area of similar figures. We've talked about what happens with similar figures in the perimeters before, but we've never exposed it to areas. So really, when we get to the new idea, really try to make sense of it. There's really only one new concept in this lesson. Okay? I want to stress that. Now, before we get to that, we have a little exploration. All right? I want you guys to answer these 3 questions. Notice it says, what is the ratio of corresponding sides? And notice it says A to B. All right, so figure A to figure B. Now, before we do this, what do you notice about these figures?
They're both rectangles.
Okay, but what's true about these rectangles?
That they are similar.
They are similar. So that's why we're finding the ratio of the corresponding sides and the ratio of the perimeters. So we already, and the areas as well. We already know they're similar, and we could kind of prove that, all right? I want you guys, and again, a ratio is a comparison of 2 things. So if I was talking about corresponding sides, all right, this side 4 would correspond to
the side 10.
Side 10. So this is what you mean. So you can write it as I usually do a fraction and then simplify it to
2/5.
Okay? So your task now is to find the ratio of their perimeters now, right? And then find the ratio of their areas. Okay?
Do that and then come back to us.
Okay. So the ratio of the perimeters, which means we're going to need to probably find the perimeters.
Right.
Right?
So we know we're adding all the sides. We've got 4 and 8 and another 4 and 8 that aren't shown there.
So the perimeter of that one
is 24.
What's the perimeter of figure B?
Figure B, if we, again, add up all the sides, would be 60.
Okay. So if I was finding the ratio of A to B's perimeter, you would do 24 to 60. And if you simplify that down, it is
2/5. All right, and we did explore that a little bit before, that the perimeter ratio is the same as the side length ratio, which is the same as the scale factor.
So if you remembered that, you could have just bypassed finding the perimeter of those 2 figures and just said 2/5 is the ratio.
True.
Okay, so just remember that. All right, let's find the ratio of the areas. Now this is the new idea, so we're going to find the area of this figure. So what is the area of the figure A?
We'd take base times height, so 4 times 8 would give us a 32. And over there for figure B, if I take base times height, that would give us a 200.
All right, so if I compare that, so it'd be 32 to 200. Whoops. It simplifies down to
4/25.
Obviously not 2/5.
The same.
Okay, so what are we noticing? Now, we already noticed that the ratio of the corresponding sides was the same as the ratio of the perimeter. So these are the same. But really the question is, what about the area ratio? What are we noticing
about it?
Yeah, what's special about it?
Well, it's not 2/5, but really 4 and 25, they're both perfect square numbers. And 4 would be a 2 squared, and 25 would have been a 5 squared.
So if I take the ratio of either the corresponding sides or the perimeters and I square that ratio, I'm getting the 4/25, aren't I?
Yeah.
So this is kind of convenient, okay?
And that does work every time.
It does work every single time. And this is actually a theorem we're going to kind of write down here. So if I know the ratio of the sides or the ratio of the perimeters, I can find the ratio of the areas without actually finding the areas. All right? So we're going to jot down this idea. Now, this is really the only new idea. Okay? Now, the stuff in blue is just a reminder of what we learned back in Chapter 8. So if it's 2 polygons are similar, then the ratios of their perimeters is the same as the ratio of the lengths of their corresponding sides. So this is something we've learned before. Okay? So the perimeter ratio is the same thing as the side ratio. Okay? So again, the perimeter ratio, and this has to be similar figures. This is only work. So the perimeter ratio is the same as that side ratio.
And we also talked about that's the same as the scale factor. It's the same as if I compared any of the heights or any of the, corresponding diagonals or any lengths.
Yes.
Any linear lengths.
Okay, so if you look at the theorem, this is the new piece. It says the areas of similar polygons. Again, it has to be similar. So most of these are going to they're going to probably tell you they're similar, or you'll be able to tell they are because they give you the information to determine that. It says if two polygons are similar with lengths of corresponding sides in ratio of A to B. So kind of like the last slide, that ratio of A to B would be in 2/5. Okay? They're saying the ratio of their areas is the A squared to B squared.
Sounds good.
So the ratio of the areas is equal to the ratio of the sides squared. Huge, huge, huge idea. This is really the only new piece, right? Really make sure you understand this, okay?
And it doesn't seem hard, but there's going to be mistakes made.
Oh my gosh.
We're going to make sure we try to emphasize those things as we go.
Okay, so let's do some examples because this is the only new thing.
All right. So this one says the ratio of corresponding sides, they give us the ratio, for two similar hexagons is 3:2. Now, honestly, we don't even need to know that they're hexagons.
Nope.
They could throw in any figure and it won't matter. We know the ratio of corresponding sides.
Okay.
If we know the ratio of corresponding sides, what else do we automatically know?
Well, the ratio of corresponding sides is the same as the ratio of the perimeters, so that means the ratio of perimeters is also 3:2.
And we're not going to care if you want to write it as 3:2 or 3/2. Either
Same
way
thing.
that you want to write, however you want to write that ratio. Now, what about the ratio of the areas?
Well, they're not the same, so I want to remember the ratio. Anytime I see area and I'm dealing with similarity, I'm going to remember the area ratio is the side ratio squared.
Okay.
Okay, so I'm going to remember that, the side ratio squared. So I'm going to take that side ratio of 3:2 and square it.
Times 2, but yeah. So I want to take that 3:2 and square it, and that means I want to square each piece. So it'll be a 3 squared to 2 squared, or a 3 squared over 2 squared. We don't want to just leave it like that. What is 3 squared?
9
2
to 4.
4, or 9 over 4. Either way you want to write that.
Now, either way, guys, make sure your ratios are simplified, so just something to remind yourself as well, okay?
And these already are, so we're good.
Okay. Read the next one. It says the ratio of the areas of two similar triangles is 32:24. What is the ratio of the perimeters? Now, here's what I want you to remember. When you see something with areas and you see similarity, okay, I want you to remember, again, this area ratio is equal to usually your side ratio squared. Now, what's the same thing as your side ratio?
Your perimeter ratio.
Perimeter ratio. So this could be perimeter ratio. Doesn't matter. Okay, so I want you to remember that. That's always something I want you to remember. A lot of times I encourage you to even write that down as a reminder. Now, notice this time, what are they giving us?
They're giving us the area ratio, so now we're working backwards.
Okay, so if I give you the area ratio, now we wrote it kind of like this. I'm going to write it as a fraction. And I want to just kind of stress something about this one, okay? A lot of times people struggle with this one for a couple reasons, all right? I know you're thinking backwards. So this area ratio is your side or your perimeter ratio squared, okay? So how do I go to get this? What am I going to have to do to get that perimeter or side ratio?
I'm going to have to undo the square, so I'm going to square root.
You're going to end up having to take the square root to get that area ratio. So in other words, we're taking the square root of this ratio here. Now, what do you think that I'm going to suggest, Ms. Hoker?
I think you're going to suggest to simplify that first ratio.
Yes. Guys, you can square root this fraction, but it's a lot easier if you simplify this first.
Absolutely.
So let's simplify this first. So again, I want to stress this. We're going to simplify first. So what does 32/24 simplify to?
Well, when you divide them both by 8, you get 4/3.
Okay, now I'm going to take the square root of that fraction, which essentially means I'm going to take the square root of 4 and the square root of 3, which simplifies down to
2 over radical 3.
So much easier to deal with. Now, what do you notice also?
Well, I'm noticing that it's not rationalized yet. So
and we want to
go
do
ahead
that.
and rationalize that denominator.
So multiply the top and the bottom by radical 3. So I get
2 radical 3 over 3, and that would be a simplified ratio.
So again, if you're working backwards, if I give you the area ratio, you're going to get that perimeter or side ratio, you're going to take the square root to kind of think backwards here.
Okay. All right. For this next one, they tell us the ratio of the lengths of corresponding sides of two similar triangles is 4 to 19. So we've got the ratio of lengths of the corresponding sides. We have our side ratio. Okay. The smaller triangle has an area of 12 squared inches. What is the area of the larger triangle?
Okay, so I immediately am noticing this. I'm dealing with similarity, and I'm dealing with area. So I'm going to remember that the side ratio squared gives me the area ratio. I'm going to remember that.
Love it. And which ratio do they give
They're
us?
giving you the side ratio is 4 to 19.
4 to 19 is the side ratio. So I'm going to put it just on that side where I've got side ratio. All right. Now, and is that a simplified fraction?
It is.
All right. So that's a good sign too. Now, they tell us the smaller triangle has an area of 12 squared inches. Okay. So I'm thinking that's part of this area ratio. Doesn't that sound like that to you? Now, here's the thing. Are these two sides just a side ratio equal to the area ratio?
No.
No. So when I try to make a proportion to solve for a missing part, let's say big A for area, what am I going to have to do to this ratio to make them equal?
I have to square the side ratio.
So really, 4 squared over 19 squared should then equal my area ratio.
Guys, notice what Ms. Hellgraby did there. The biggest mistake, take those squared off for just a second. This is exactly what people will do. They will just say the side ratio is equal to the area ratio. And they'll cross multiply. They're like, oh, this is a piece of cake. Well, yeah, solving a proportion is easy. It's can you set it up correctly? So don't forget, it's always the side ratio squared that gets you the area ratio.
And I also realized I just kind of put the number 12 in here.
Oh, yeah.
Why did I put that in the top instead of
because it's the smaller triangle, and since the side ratio says 4 to 19, the smaller side is the 4.
Right. Okay. Just to make sure you guys all see why I put that there.
All right, put those squared back in there.
All right.
All right. So let's square 4, and you get 16, and 19 squared is 361. And that's going to equal the 12 over A. And again, 12 over whatever the other area is will simplify down to 16 over 361 because it's the side ratio squared.
And since you notice this 12 is a little smaller than the 16, this area should be a little less than the 361. Let's go ahead and let's solve. So 16A
is equal to 4,332.
And when we divide by our 16,
you get 270.75. And this is going to be in square inches.
Squared inches. Love it. Because they give us units on this too.
And that's why you can leave it in decimal form too. Right? I didn't have to round. This was an exact, so you didn't have to worry about that either.
Right. We cannot stress this enough, guys.
Oh my gosh.
This right here is the mistake that people will be making.
Yes.
Be careful. And I love that Mrs. Palermo just suggested, let's talk about this is the side ratio squared equals the area ratio. If you have that at the top of your paper, you can kind of keep reusing that idea over and over again for these problems.
And guys, just think about how easy solving it is. It's just solving a proportion. That's why most of you are going to be like, this is not that bad. Well, it doesn't need to be, but you just got to remember this idea. All right, let's try another example. It says a rectangular tablecloth is 60 inches by 120 inches. The rectangular placemat made with the same cloth is 12 inches by 24 inches, and it costs $5. Find the cost of the tablecloth. So here's what I would suggest. Maybe let's kind of sketch visual here. We have a rectangular tablecloth, all right, and it's 60 inches by 120 inches. And just a reminder, when you're talking about the dimensions here, usually the smaller is the width, this is your length, okay? We have a tablecloth with the same material, or the placemat, sorry, of the same material, and it's 12 by 24. So notice I put the smaller one here. I'm going to put the smaller one here. Okay,
and that this way one, they kind of gave them to you in order, but that won't always happen.
Yeah, so just keep that in mind. Smaller with smaller. You want to make sure it's corresponding. Now, since they're both rectangles, we know that all the angles are going to be right angles. And if you compare one side to the next, all right, they're going to have a
They're proportional.
proportional sides. So that means these are similar. Okay. Now we know the cost of which one?
We know the cost of the placemat is $5. And just in case you guys have never purchased fabric before, you purchase it by the square yard usually, or the square inches in this case. So we're purchasing it by its area.
Yeah, think about why that is, guys. You're purchasing, this is the cloth, all right? You're dealing with area because you're purchasing the actual material, all right? So I'm
not buying the thread and then having to make it your...
You're not going to purchase the perimeter around it. Well, then it's not actual cloth. So we are dealing with area in a sense and similarity. So when we think area and we think similarity, I want to remember
that the side ratio squared equals the area ratio.
Good. All right. So how can we go about doing this?
Okay. Well, I am thinking that we're going to need to find, first of all, the areas of both of these figures.
Okay.
Okay.
And I can actually think of a couple different ways about doing this, but I like Ms. Hochgrabe's suggestion because finding the area, since we're dealing with
we're
the
going to need
space.
that. Okay. And so I could also go with the side rate. Which one you want? You want to do the area?
Let's find the area.
Okay,
Let's try
we'll
it this
talk
way.
about both.
Because bottom line, guys, this one you can go about it a couple different ways. Okay.
Yes.
So if we could find, we can find the area, all right, and that's would be just 60 times the 120 for this one. So the area of that figure is
7,200.
And then the area for 12 times 24
is 288.
I don't know if you can see that very well. Let's see if I can get rid of my coloring without.
Hey, look at that. Good job. Okay. So that's one approach.
Okay.
Because we're talking about their areas. And I can make an area ratio now.
Okay.
And it doesn't seem to matter which one I start with because they didn't specify. So let's just say our 7,200 over 288. And I probably want to then simplify that. Let's see, that's going to give us 25 to 1.
Now, the reason why, and we'll talk about this in just a minute, why you don't have the area is because this is the area ratio, which is the side ratio squared. So we'll talk about what I mean by that in just a minute, okay?
Right.
So why, again, are we dealing with area is because the cost involves the space inside, basically, the cloth, the actual cloth. So this is your area ratio. Now,
the cost is based off the area. So I really want to use the area ratio when I'm setting up a proportion to talk about the cost.
This area ratio is going to be the same as your cost ratio in a sense. So this is obviously the bigger one. So you put 25 over 1 equals, now do we know the cost of the
Let's
tablecloth?
just call it C for cost.
Okay, and we don't know, over the cost of the tablecloth, which is
the placemat is $5.
or the placemat, sorry, is 5. So then when you go ahead and cross multiply, the cost of the placemat is,
so $125
or the tablecloth,
yeah,
$125. Expensive tablecloth.
Woo! I don't know that I'd want to pay for that.
It's probably,
that better be some premium fabric right there.
Maybe it has some diamonds or jewels or something.
Who knows?
Now, here's the deal, guys.
That's one approach.
I personally, and I like how Ms. Hochgrabe started because I know most people think of that. Okay, so she was thinking, what would you guys think? But I purposely, again, want you to have you think of this because if you know the side ratio, which you do know the dimensions of both of these rectangles here.
Yeah.
So could we find the side ratio? Well, this side to that side, so
60 over 12
simplifies to 5 to 1.
Yeah, 5 to 1.
This is your side ratio. Now, what could you do with the side ratio to find the area ratio?
Just square it.
You square it. So if I square the 5 to 1, I get the 25 over 1, which is the area ratio we found when we found the areas. So the cool thing about this problem is that because they gave you the dimensions of both of the figures, you could find the areas. But if they don't give you the dimensions, you could use the side ratio squared idea. Okay?
Yes, perfect.
It just depends on how you want to go about it. Okay? Again, don't forget, this is one where we forget we're using area. All right? Okay, I think we have
All right, let's take a look at this
another
next
problem
one.
here.
It says a store sells trampolines that are regular hexagons. And a trampoline has a side length of 4.5 feet. So there's our side length of the trampoline. And an area of 52.6 square feet. The area of a trampoline whose perimeter, or we're finding the area of the trampoline whose perimeter is 67.5 feet. So we've got two trampolines we're comparing.
Okay.
All right. Let's talk about them. Trampoline 1 and trampoline 2. I'm just going to kind of compare so we know what pieces we have. What do you know about one trampoline that they tell us?
One of the trampolines says the side length is 4.5 feet. Now, one thing to keep in mind is these are what kind of figures?
They are regular hexagons.
Sometimes that doesn't matter, but I just want to encourage you to maybe think about that if we need it. Okay, we also know the area of that trampoline is to be, it's 52.6. And they're all in feet, so
right.
not have to
We're
worry
not going to worry about labels right now. Okay, do we know either the side ratio or the area ratio for trampoline 2?
No, it says the area ratio we don't know, but we give the perimeter. So let's put the perimeter is equal to 67.5 feet. So that right away tells me we need to figure something out. And then the area is our unknown.
Right. Now, I will have some students that will say, well, the side ratio and the perimeter ratio are the same, so they'll just put them in a ratio together. Be careful, because the ratios of the sides and the ratios of the perimeters are the same. But sides and perimeters do not go in the same ratio.
Because they're two different things.
Two different things. But when we know a perimeter, we definitely know the number of sides. So if I took this divided by the 6 congruent sides, that's going to give us what?
Let's see. 11.25. Now, could you also find the perimeter of the trampoline 1 and just multiply that by 6 and find the perimeter?
Yeah, absolutely. What is that?
Let me see it. Times 6, 27.
Now, actually, that's a great idea. Let's talk about this. Would you rather use the whole value with the 67.5 or use this 4.5 with our 11.25?
It doesn't matter to me.
Doesn't matter to me either.
It's gonna be. It's gonna get you the same outcome.
Yes.
Okay. Okay, but I am gonna remember this one thing. We're dealing with similar figures, and it is area ratios. So I'm gonna take the side or the perimeter ratio, square it, and that's gonna equal your area ratio.
Wonderful.
Let's do the side ratio.
Okay.
So I'm gonna do 4.5 to the, what, it was 11.25? You almost did it. And then we're going to square that side ratio. And that's going to get you the area ratio. So the area of trampoline 1 was 52.6, and we don't know the area of that one.
Okay. Sounds great. And what do you get when you take your 4.5 squared?
20.25.
And the 11.25 squared?
Okay, this is 126.5625, and that's exact.
All right. And then we've got our 52.6 over A. And from here, it's just cross multiplying.
Okay.
Work. And I'm going to let you guys do that on your own, and we just end up with an area that is
328.75 feet squared. And that's exact.
Love it. All right.
Okay.
Last one.
It says the dimensions of a rectangle are 4 inches by 10 inches. What are the dimensions of a similar rectangle with exactly triple the area? All right. Now, here's a couple things I'm noticing. Similar and area. Okay. So what are we going to remember?
That the side ratio squared is equal to the area ratio.
Hopefully that is ingrained in your brain. Okay.
If not, it's not our fault.
I know.
We're trying.
Okay. So we're dealing with a rectangle that they say is a 4 inch by 10 inch. They're saying what's the dimension of one that's similar. So the dimensions, when they say what are the dimensions, we're basically wanting to find the width and the length, right?
Right.
Or the base and the height, however you want to word it.
Right.
So those are our question marks, okay? So how are we going to go about doing this?
Well, they kind of give us the area ratio.
Why is that?
Because they tell us that we are looking for the area to be tripled. So they don't tell us what the numbers are, but we're looking at a simplified ratio when I think about tripled. So, like, for example, it would have a ratio of 1 to 3.
So that's because this one is 3 times as big as that one.
Right.
So this would be the area ratio. I like that you started that way. Is equal to 1 over 3. Okay, this is 3 times as big as this one.
Right.
Okay, if
we could have said 3 to 1, but then we were going to start with our unknown.
And here's the
every
deal.
time.
You could do that. And here's the deal. You could, if you're like, well, let's find the area of that one. So this would be 40. If I triple this one, you get an area of 120.
Still simplifies.
40 over 120 simplifies to 1 to 3. So I love that you started that way because bottom line, it's a lot easier. Okay?
All
right.
You guys are welcome to find the area and triple it.
Yeah,
But
this is just less work.
shortcut.
All right, so we know the area ratio is 1 to 3. So that's the piece we know. We're wanting to find the dimensions, okay? So the side ratio squared gets you the area ratio, right?
Right.
Okay. How are we going to do this?
Well,
How
we
are we gonna
know
do
to
this?
work backwards, we know we want to take the square root.
Okay, of this area ratio.
Of that area ratio.
So this, we're going to take the square root of this to get you your side ratio.
Uh-huh.
Okay, so that's going to give you your width to your length, basically.
Okay.
Okay.
Which square root of 1 is just 1. Square radical 3, we might want to rationalize
So this
that a
would
little
be
bit.
1 over radical 3. Now, we can rationalize it, but we're actually, what are we going to do with this? What are we going to do with this?
Well, we know we need to be able to get to the dimensions. And we know the simplified dimensions. So how do we get to those original dimensions?
Okay, so if this is your width
Uh-huh.
and this is your width, okay, this to that is your side ratio. 4 to W is a side ratio. So this right here is your side ratio. I'm going to set that equal to 4 over W.
Okay, so since they really do give us a side, we can find our one missing
Okay,
side.
so basically you're going to do a little cross multiplying. So W equals 4 times radical 3. Now, since there's units, we probably are going to round.
Okay.
So why don't you put that in your calculator?
And 4 radical 3 is going to give us a 6.93 if we round.
Inches, right?
Squared. Or inches.
Just inches.
Sorry, we're not doing
Now,
area on this one.
Since this is your, again, this is your side ratio, we can take that same side ratio and set it equal to your length to length. So it would be 10 over L. Okay? So notice when you cross multiply, you'll get the length equals 10 radical 3, which is approximately
17.32
Now,
inches.
how could you check to make sure? Well, these are rounded answers, so it's not going to be exact. If you take 9.73 or 73, gosh, 6.93, gosh, I'll get it right, times 17.32, you should get an area that's around 120.
In fact, I'm going to leave that exact 17.32 in my calculator because I still had that. And I'll just take it times the 6.93. And that's going to give me 120.03. So
Yeah.
super close, but I left that one rounded.
You could also multiply
and if
4
I take it times
radical
4 radical
3.
3, it's exact.
So that's another way of doing it. This one's a little bit more challenging because you got to think about finding this side ratio first. And with radicals, it's a little bit more challenging.